So today I'm going to look a little bit more about managing instances of objects. So I'm going to go back to the game of NIM implementation. Here you're seeing the artificial intelligence making some moves. Let's take a quick look at the actual game itself. So notice that once we've asked to play, while the piles are not all empty, we're going to take turns. The player takes a move, and then we give the results. Then the AI is asked to make a move, and again we make sure that it's valid and then go through the process of actually making that move and showing the results. Alright, so let's take a look at especially what I'm interested in is the AI taking a move. And here what I'm doing is I'm passing in as an argument these piles. So these are the 3 piles of stones that is being passed in as an argument both to the player when they're asked to make a move and to the AI when they're asked to make a move. And these are the piles that are part of the game. Okay, so this is the set of piles that we're playing the game on. Alright, so let's run this. I'm going to choose the hard level. Enter my name. So I'll just choose pile 1, take 1 from pile 1. Now notice what happens with the AI. It said that to take 1 from pile 1, I ended up with 0, but notice that 1 had been taken from pile 2 and 1 had been taken from pile 3. There's certainly a mistake in the program, but let's take a look on how that mistake could happen. And I'm going to look at a different way of removing that. So remember that I put it on a hard game. And so what we're doing is we're calling winning move to decide what move we're going to make, which I've just for convenience put up here. So what does winning move do? It gets these piles that we're currently playing the game with. It chooses some random move, it takes the stones, chooses another move, takes the stones, chooses another move, takes the stones, and then it just makes some kind of a random move, and that is what is going to be returned. So notice what this here was doing is it was actually changing the piles of stones that we're playing the game on, and that was not the intent of this method. It's actually known as a side effect. But it's not the intent. We only wanted to give these piles as information, not so that the artificial intelligence could change it. Now we could just say, well, let's just fix it here, but one thing that we do with safe programming is try to prevent it from happening altogether. So what we want to do is instead of passing the actual piles that we're playing the game with, we just want to pass in a copy so that the AI can use it as information, but cannot actually change the state of the game itself. It can just tell us what move it wants to make, but the game itself decides the move that is made. So here with the AI, instead of passing it the actual instance of the piles, I want to make a copy. And remember that one thing that I was working with is that the easiest way of doing this is using a copy constructor. Okay, so I can call this piles copy of piles is equal to new piles, and I'm going to use the existing one, so I'm indicating that I want to make a copy. So instead of using the original, I want to pass in the copy of the piles. One thing is that if I want to be able to do that, I have to make sure that I have a copy constructor. So let's take a quick peek in piles. And notice that it has the default constructor, which doesn't take any arguments, and one that takes 3 integers. So I also want a copy constructor, so let's add one more, which takes to copy. Okay, so this is the one that we want to copy, and the quickest way of doing that is just directing to the other constructor by using this, and just taking to copy dot pile 1. Actually, it's best actually to copy it over directly. If for some reason a pile is set at 0, we want to keep it at 0. So pile 1 is equal to copy dot pile 1, and my pile 2 is equal to the one that I'm supposed to copy. So I'm going to grab that out of there, and my third pile should be the same as the other ones. Third pile, So now I've just made a copy of the one that was given in to me as an argument. Okay, I can save this. And let's see what of a difference this makes. I better the AI, I want to leave unchanged, because any changes that it makes, it should now make to the copy. And I want to make sure that this here is saved as well. I can stop this one. And run the game. Hard level, because I want to make sure that we're using that methods that changes to piles, or at least attempts to do so. Alright, so I'll do the same thing. I'm going to from pile 1 take 1, and in this case the computer was asked to take 1 from pile, or said it wanted to take 1 from pile 1, and that's indeed the only change that was made. Pile 1 has been reduced in size from 2 to 1, and piles 2 and 3 have remained unchanged. Right, so even though the method made changes, since it was making changes to copies, so if I go back to the AI, because I was making changes to the copy of the piles that were passed in, so I got here a copy, all of these changing of the piles made no difference. It made no difference for the game itself. So this is a much safer way if the game itself does not want the AI to actually change the state. It doesn't want to change the piles. It should only use it for information. Then a copy should be passed in. And of course the same should be done for the player, the human player. So this one also should have gotten a copy of the piles. Okay. And this is now a proper way of encapsulation. Okay, so there are no leaks here, no privacy leaks, by giving them a copy instead of the original.